Howdy folks, this is Mr. Von Ah, and I'm here to help you with your algebra. And we are learning about inequalities. Okay, we've learned how to solve and graph inequalities. And in this video, we are going to learn how to translate word problems into inequalities. All right, this is really where the rubber hits the road, right? Word problems are the hardest. Word problems is what's mostly going to make up the test that you're going to be taking. If you can learn how to set these up, you will be in good position to pass any test. All right, not to mention just in life in general, because life is a test. All right, so we've been learning about word problems, and I've just been sharing with you basically a two-step process of how to think algebraically. All right. So the first thing we need to do is we need to define our variables. Okay, what are we talking about? What are they asking for? The variable is going to be what they are, the value they are actually asking for at the end. Okay, what's your variable? Define it. Okay, and then understand which operators are involved. Add, subtract, multiply, or divide, and where they're located in the inequality. Okay, and another thing we're going to have to do is we're going to have to figure out which inequality symbol that we're going to be using, right? Less than, greater than, and so forth. All right, so don't forget, in the description below I have a link where it takes you right to the notes for this lesson. All right, well, without further ado, let's jump right into example number 1. Okay, so example number 1 says this: 8 less than the product of -3 and a number is greater than -26. What is the number? All right, so what's the first thing I do here? First, I need to define my variables. Okay, what is this about, or what are they asking for? Well, they're asking for the number. They're asking for the number. Where else do you see that? Well, you see it right there, right? So our variable is going to be a number, right? So we have to define that. What are we going to use? What variable are we going to use for a number? We could use x. How about this time we use the letter n for number? Okay, so I'm going to say let n equal the number, or a number. Okay, now once we have that defined, now we need to understand, okay, which operators are involved here? Okay, so we have 8 less than. Many times people think, well, that means that's an inequality, right? That means 8 less than. No, what you're going to discover is usually your inequality symbols are going to follow the letter is. All right? So it's not like that. So 8 less than, that just means -8. Okay? So for example, if I have $10 and you have 8 less than me, you have 2. Well, you had to put my 10 out in front, right? Okay? So 8 less than 10 is 10 minus 8. All right? So I'm going to go ahead and put -8, not 8 minus. So 8 minus, okay, 8 less than what? The product. Product means multiplication. The product of what? -3 and a number. Oh, there's our variable, right? And a number. What do we use for a number? Right? Instead of saying number, we're going to say n. All right? So we could say like this: 3 times a number -8. Okay? But we already know what a number is. It's n. Okay? So instead of putting number there, we can just say 3n, -3n. So -3n -8, sorry for all the erasing. So this is 8 less than the product of -3 and a number is greater than. Greater than. that means all of this has to be greater than negative 26. So it's going to be this direction, right? The big end is facing this, because all of this has to be greater than this. All right, see how the big side is facing this side and the small end is facing the right side? Okay, there it is. 8 less than the product of negative 3 and a number is greater than negative 26. Okay, now from here, what you would do is you would solve for n. And I'm not going to solve it in this video because we've solved it in past videos. I want you to pause this video now. I want you to solve this inequality. At the very end of this video, I'm going to give you all of the solutions. We're going to do 5 of these examples. I'm going to give you all of the solutions at the very end. All right? So let's go ahead, now that you've paused it, let's go ahead and move on to example 2.
1.
All right, so let's move into example 2. So this one says the sum of 2 consecutive integers is at least negative 15. What are the values of the 2 integers? All right, so again, I have to define my variables. What is the problem about, or what are they asking for? Well, they're asking for the value of 2 integers. All right, they're asking for the value of 2 integers. Okay, so that tells me what my variable is. Okay, so I'm going to let, this time I'll choose x. You can choose any letter you want. I'm going to let x equal an integer. How do we want to say that? Let x equal, what are the values of the 2 integers? Integer. Okay, or you could say the value of the integer. Right? Doesn't really matter. Or you could say the first integer. Maybe that would be a better way to say it. All right. X equal, because I'm going to have 2 integers here. Okay? 2 consecutive integers. So the first integer is just x. Okay, so it says the word consecutive. What does that word mean? Well, if a consecutive just means one after the other, like 3 days in a row or 3 days consecutive, right? So if I'm speaking in consecutive numbers, I'm speaking like 1, 2, 3, 4. All right, those are consecutive numbers. Okay, so if x is my first integer, what will be my second integer? Well, it's just going to be one more than my first integer, right? So I can just add 1. So x plus 1. Right? There you go. I have my variables defined. My 2 integers. All right, now I need to understand, okay, where are my operators here and where do they fit? Okay, that's part 2. Okay, the sum. That's an important word. What does sum mean? Well, that's the result of addition. Okay, so that means I'm going to be adding something. What am I adding? The sum of 2 consecutive integers. Ah, well, aren't these my 2 consecutive integers? Here's my first integer. There's my second integer. So I need to take the sum of these 2 integers. How would I do that? Well, I'm going to change color here. Sum just means plus. So that means I need to take my first integer and add it to my second integer. This is the sum of 2 consecutive integers. Okay, is what? Okay, there's that word is. So important. That's going to be my sign. Hey, I got an equal sign coming here, or I have an inequality symbol. Okay, is at least. At least. What does that mean? Okay, so if I said, hey, you need at least $20 to come to the party. Well, that means that you can bring $20. That'd be okay. You could bring 21. You could bring $50. but you cannot bring 19, right? At least means more than or equal to, right? Greater than or equal to. So at least is greater than or equal to, right? Key word there is at least negative 15. They wrote the whole thing out. Right? So I can just write it just like that. All right, so there is your inequality. The sum of two consecutive integers is at least negative 15. Okay, pause the video and see if you can solve for x. And I'll just tell you, you're going to get two answers. You need a value for your first integer, and you need a value for your second integer. Okay? As I pause the video, I want you to go to work. All right, so let's take a look at example number 3. All right, example number 3 is a guy named Connor went to the carnival with $22.50. Okay, he bought a hot dog and a drink for $3.75. He wanted to spend the rest of his money on ride tickets, which cost $1.25 each. What is the maximum number of ride tickets he can buy? All right, so once again, the very first thing is I got to figure out what is my variable. What is my variable? All right, right here. Okay, again, the variable is going to be, hey, what is this about and what are they asking for? A telltale sign is look at the end of the question. What is the question? What is the maximum number of ride tickets he can buy? There's your variable, right? It's a variable because that's the unknown. They're asking you that question because it's unknown, okay? So that's how you can pick off your variable really easy. Ask, hey, what are they asking for? Okay, that's your unknown. So ride tickets, there's my number of ride tickets. Number of ride tickets, that is what the variable is. Okay, so I'm going to go ahead and define that. I'm going to say, let's use a different color here. I'm going to say let, how about R? Huh? Let R equal the number of ride tickets. All right. Okay, so now I can go ahead and figure out where my operators are located and what they are. What are the operators and where are they located? All right. So Connor went to the carnival. Okay, that's his total amount of money he has. Okay. He bought a hot dog and a drink for $3.75. He wanted to spend the rest of his money on ride tickets, which cost $1.25 each. Okay, so let's kind of break this down before we get into all the numbers. Okay, so he's got $22.50, right? And he wants to spend on food costs. So he's going to spend money on food. So food. All right, hot dog and a drink. Plus he wants to ride some rides, right? So food costs plus ride. So you could say food cost plus ride cost. Okay, and he only has $22.50 to spend. Okay, so that it's all he has. So that's going to come over here. $22.50. Now the question is, what symbol do I have here? Well, it says here, what is the maximum? What is the maximum number? Okay, so what inequality symbol is that going to be? Well, is it going to be that one, this one? I mean, which one's it going to be? You got 4 different options. Okay, if I said, hey, you have a maximum of 5 minutes left on the test. Okay, can you go 6 minutes? You can't go 6 minutes, right? You can go 4 minutes, would be fine. Can you go 5 minutes? Yeah. You can go up to a maximum of 5, but nothing more than 5. So that means it's going to be equal to or less than, right? So when you see that word maximum, it's just a way of saying, hey, less than or equal to. So it's going to be right there. They say learning how to decipher the language, the inequality language, is a skill on its own. Okay, so that's basically the inequality. Food cost plus ride cost is less than or equal to $22.50. Okay, now let's throw some variables and numbers in it. Okay, food cost. What's the food cost? Well, we bought a hot dog and a drink for $3.75. Right? There's no variable there. We know all that. So that's going to be $3.75. You can put the dollar sign there if you'd like. Plus the ride cost. Well, what's the ride cost? The ride tickets are $1.25 each. So that means if he rides one ride, it's going to be $1.25. If he rides 2 rides, it's going to be $2.50, and so forth. All right, so I'm just going to multiply the cost of each ride by the number of rides that he rides. Well, what's the number of rides? Number of ride tickets, right there. See how important it is to define your variable? I just erased. R. So $1.25 per ride is less than or equal to $22.50. There is my inequality written out in all of its grandeur. All right? So I'm going to let you try to solve for R. Okay, so go ahead and pause the video and come back, and at the end of the video I will give you the solution. All right, so now let's take a look at example 4. I hope you're starting to get the hang of this, right? So, all right, Stan earned $10.55 an hour plus $100 in tips waiting tables over the weekend. He earned $260 in total. To the nearest hour, what is the least number of hours Stan would have to work to earn this much money? All right, so under normal circumstances, this would be like mind-boggling, like, well, I have no idea how even to begin this problem, but hey, we have a process. First, we define our variables. What are they asking for? See that word? What is the least number of hours Stan would have to work? There's my variable. My variable is the number of hours Stan would have to work. Let's do this problem in purple. So what do you want to use for number of hours Stan has to work? How about H? So H, I'm going to say let H equal the number of hours Stan must work. Where did I get that from? Right there. There's your variable. That's what they're asking for. Okay, the variable is the unknown. Hence, which is why they're asking. Okay, so let's kind of break this down before we get into the numbers. Let's kind of see what's going on here. What's Stan doing? Stan's working over the weekend. He's earning an hourly wage, right? So we get an hourly wage. Right? He's earning $10.55 an hour, but he's also earning $100 in tips. What operator would that be? Add, subtract, multiply, or divide? I would just add, right? His hourly wage, and just add the tips to that. So add his tips, and that's going to come out to 260. Right? He earned 260. Now here's the big question though. What inequality symbol are we going to use? Is it an equation or is it an inequality? Well, let's look. Where do you see a word in there that tips me off that this is an inequality? Right there. Right? If it just said, what is the number of hours? that would be an equation. But that word least is an inequality. Okay, the question is, which symbol is it? Is it less than, greater than, less than or equal to, or greater than or equal to? Pause the video and select one that you think is correct. All right, so what is the least number of hours? So if I said, hey, you need to score at least 80% on the final to pass the class. You need at least 80%. Would it be okay if you got an 85%? Sure. What if you got a 79%? You didn't pass, right? So if I say you need at least, it means you need more than or equal to. Okay? So that's going to be that one right there. Did you get it right? All right. So now that we got this kind of written out, let's put in some numbers and variables now. Okay? So hourly wage. What's his hourly wage? $10.55 per hour. Per hour. So if he works 1 hour, he earns $10.55. If he works 2 hours, he earns, what is that? $21.10, right? So each hour is going to be multiplied to $10.55. Do we know how many hours he worked? We don't. That's what we're trying to figure out. We're trying to figure out the number of hours. Okay, so we're going to have to put an H right there. So 10.55 times how many hours he works plus tips. Do we know how much he earned in tips? $100. And that's greater than or equal to $260. Now there's my inequality. Right there. That's the hard part, setting it up, right? Now I'm going to let you solve this. Okay, pause the video and solve this inequality. And I'll give you the solution at the very end. All right, let's take a look now at example 5. Example 5, Brenda. She has $500 in her bank account. But every week she has to withdraw $40 for expenses. If she does not make any deposits, how many weeks can she withdraw this money if she wants to maintain a balance of at least $200? All right, so again, seems pretty daunting, right? But once we learn how to think algebraically, we can really translate this into an inequality, solve that thing. We can tackle, see how we can tackle complicated problems? We can learn to think algebraically. All right, so first we need to define our variable. The variable is the unknown. What is unknown? What are they asking for here? Well, you look right at the end of their sentence, at the end of the problem. How many weeks can she withdraw this money? There it is. There's your variable. So what would you like to choose? What letter would you like to use? How about W for weeks? That sounds pretty good. So I'm going to say let W equal number of weeks Brenda can withdraw. All right. You could just say number of weeks. All right. Now here's what I'd like you to do. I'd like to see if you can go ahead and pause the video and see if you can do step 2, which is figure out where all the operators go. All right. Give it a try. All right. Well, welcome back. Let's take a look here. So she's got $500 in her bank. And she's withdrawing $40. Withdrawal, what does that mean? That means she's taking money out of her bank account, which means her bank account is getting smaller and smaller and smaller, right? Well, is that adding, subtracting, multiplying, or dividing? That's subtracting, right? So she starts with $500. So she starts with $500. But then she has to subtract. She has to subtract what? $40 each week. Now, how many weeks is she going to do that? Well, that's the question. We don't know how many weeks. Well, it says right here, number of weeks Brenda can withdraw. So if she withdraws it just 1 week, that'd just be 40 times 1. So you get what? 460. If she withdraws for 2 weeks, that's 40 times 2, which is 80. Okay, but we don't know how many weeks. So we're just going to put W because that's our variable. Okay. Now, how many weeks can she withdraw if she wants to maintain a balance of at least $200? So we got a 200 over here. Okay, at least. What does that mean? Does that mean less than, greater than, less than or equal to, or greater than or equal to? Well, if I say you have at least, you need at least $5, that means you need $5 or more. So you can have more than $5 or equal to $5. It's going to be right there. Okay? So if she starts with $500 and she withdraws $40 per week, how many weeks can she do it to maintain a balance of more than or less or equal to $200? And there's my algebraic statement. I'm going to let you solve that. Pause the video, solve it, and when we come back, I'm going to give you all the solutions to the 5 problems that we did. All right, so now we're going to take a look at all the solutions to our 5 word problems that we've been working on. All right, so I got them hidden here. All right, example number 1. Did you remember to reverse the sign, the inequality symbol, because you divided by a negative? We got n is less than 6. N is less than 6. Example 2, that was the consecutive integer problem. The first integer, x is greater than or equal to negative 8. The second integer was x plus 1 is greater than or equal to negative 7. All right, those are consecutive integers. Okay, example 3. Okay, the tickets, the how many tickets he can buy. R is less than or equal to 15 tickets. Means he can buy no more than 15 tickets. If he's going to have all that food. Okay, example 4. That was Stan, right? How many hours he has to work? Well, he has to work greater than or equal to 15.2 hours. And the question said, round it to the nearest hour. So we would round that to 15 hours. So he's gonna have to work at least 15 hours to get $260. Okay, and our last example with Brenda, she's withdrawing $40 a week. She can do that for no more than 7.5 weeks. Okay, so there you have it, our solutions to our word problems. I really hope this was helpful to you. If you can really learn to take an English sentence and think algebraically and translate it into either an expression or an equation or an inequality, it will serve you well on tests, and my friend, it will serve you well in life. All right? Don't forget to click on the link in the description box below. It will give you the notes for all of this. And don't forget to subscribe to my channel. And until next time, my friends, may God richly bless you.